Okay, question 2H2. Before we get to that, we need to go back over question 2H1 because this question uses some of the same information from the previous problem. Okay, so in question 2H1, we are presented with a scenario where we have two different species of panda and that we can't tell them apart except for species A gives birth to twins 10% of the time. Whenever it's giving birth, 10% of those times is twins, and species B has twins 20% of the time. Okay, and so the information that's relevant for the next problem is that we're supposed to assume that the two types of pandas are equally populated. So if we have a random one, it's equally likely to be species A as species B. So the prior probability of species A is 1/2. Okay? And then again, the likelihood here is that for species A, okay, so the likelihood of having twins if we are species A is 10%. All right. For species B, it's 20%. Let me annotate some of this actually. So this was our prior at that time. And then these were both likelihoods. Likelihood, okay. And then we also have the marginal from here. So what is the probability of having twins at the first birthing, but just having twins? Well, it's the prior probability that we have species A times the probability of having twins if we're species A, and then the same for species B. Okay, and so that served as our marginal. All right. So in question 2 here, we're supposed to, don't see that. We're supposed to use the same same information that we have above, but now we are trying to find the probability that that we have species A, given that we've observed that animal giving birth to twins. Okay. So from the previous problem, we have that species A, that the prior probability for species A is 1/2, right? So that was here, and so now that's here. The likelihood that we have twins, given that we're species A, is just 10%. Okay, that's what we had up here, and that's what we have here. And then the marginal probability is 0.15. Now we calculated the marginal probability up here, although it's not displayed explicitly, but it was 0.15, and so I've just hard-coded 0.15 into the code here. So the solution to this is very straightforward. We just plug these into Bayes' theorem. So here's our posterior probability, the probability of species A, given that we've observed twins, and so it's just the prior times the likelihood, okay, divided by the marginal, and that's very straightforward. And so we see that it's 1/3, 0.33.